Hey, this is Dino, and I want to talk to you today about a solution I put together for authentication and authorization for APIs, regardless of where those APIs run. This started from a conversation I had with a customer who said they wanted to publish some of their APIs for consumption by external partners and customers. So they wanted those partners or customers to authenticate on an individual user basis, not just business to business, but individual users. And they wanted authorization for those specific users and against specific APIs and actions on the APIs. So fine-grained authorization control and fine-grained authentication. Particularly for the authentication, this customer said in some cases the API provider, they themselves, would act as the identity provider for the authenticated users. But in some cases, the partner organization or the customer organization would act as the identity provider. They would bring an identity provider, and we'd need to establish trust in some way, maybe a SAML partnership, something like that. So federated identity. The customer said they wanted proper auditing of any changes to the authorization policies, that fine-grained authorization, and maybe even logging and auditing of authorization decisions. And they wanted it all to perform with enterprise capability. The solution I put together is based on these three elements. First, at the foundation, identity platform for federated authentication. That's Google Cloud Identity Platform. Really neat. You can set up multiple different identity providers and have a single platform rendering an ID token that can then be used by other applications. Second pillar of the solution would be Apigee for API management. That relies on the identity platform supplied ID token to authenticate the connected user, and then Apigee would enforce access control in a standard way across all managed APIs, but also delegate authorization decisions to an external service. And that external service is Open Policy Agent. Now, Open Policy Agent is not a Google Cloud technology. It's an open source technology. It is a CNCF project defining a general purpose authorization policy engine. This can be hosted as a cloud service in any container engine like Cloud Run or GKE, and it presents a lot of flexibility for defining your authorization rules. So what would this architecture look like? The flow for the user experience would look like this. A client application would be used by a particular user. They'd first sign in to identity platform, and again with multiple different ways. The result of that is the ID token, a signed JOT. Step two is the client application presents that ID token to Apigee, which verifies the token, verifies the signature on the token, it's not expired, it's valid, and so on, issued by the right issuer. And in that case, in the case that it's valid, Apigee will issue an access token, a time-limited access token to that client app. In subsequent requests, the client app can present that access token back to Apigee requesting some service. Before Apigee proxies that to the upstream, Apigee contacts the authorization engine to say, this is the user, this is the resource they want to access, this is the action they want to perform on that resource. Should I allow it or not? The responsibility of the authorization engine is just to issue a deny or allow result to the caller, to Apigee in this case. Apigee gets that response. If it's allow, Apigee will proxy to the upstream system, which can be anything. It can be custom code that somebody has written. It can be an off-the-shelf system. It can be a third-party SaaS system. In fact, it can be all of those. It's a general purpose authorization solution. And those endpoints, those API endpoints, need not be aware that Apigee is acting as an authorization layer in front of them. So in the case of allow, Apigee proxies to the upstream and then relays the response back. In the case of deny, Apigee just issues a 403 back to the original client and says you're not allowed. So that's the basic idea behind the solution elements. This is a sequence diagram that just describes in a standard way the interaction that I just walked through. So I won't go into a great amount of detail here. But I do want to show you this in action. So let me step over to my, my demonstration pillar. The foundation of this solution will be identity platform. So in Google Cloud Platform, there's a number of different services. Identity Platform is one of them, and you can set up your own identity provider in Google Cloud, specifying which providers would be federated into that model. So I set up 3: email, password, a Google sign-in, which can be any Google account, like a Gmail account or any other Google account, and also an Okta provider. And what this does is allows, through a single user interface, people to sign in from multiple different mechanisms. So let's have a look at what that would look like. First, we'll try maybe email and password. And this is just what you're familiar with. You can also set up multi-factor auth for this sort of thing. The result of signing in is an ID token. If familiar with JWT, that's what that is. It's a encoded JWT. This is the decoded version. You can see the header. Maybe more interesting is what's in the payload of the JWT. We can see the email, the sign-in provider that Google Identity Platform used to authenticate the person, the authentication time, the issuer of the authentication, when the ID token expires, and so on. So lots of interesting information. Remember, this is signing in with an email ID and password. We can also sign in with a third party. The Okta user interface for signing in. So let me sign in here. I've got an account set up. I can sign in with my Okta account, and we'll see once again I've got an ID token. So very similar. Also issued by Google. Here we have, again, the email address that's been verified, and then the sign-in provider is Okta, an OIDC provider. Then once more, I'll show you one other option, and that is the Google sign-in. When I click that, you'll see the familiar sign-in with Google prompt, and I can sign in. I'm already signed in with this browser, so I don't need to authenticate again. But again, I see an ID token. Here we see the sign-in provider is google.com, the email address, my actual email address, and again, the same issuer. So that signed ID token is the basis for identity. Regardless of which way the user has chosen to sign in, at that point, the user is able to exchange that ID token for an access token. It contacts Apigee. Apigee verifies the ID token and then exchanges that for an access token if the ID token is valid. Okay, so that's the first 2 steps in that diagram that I showed you earlier. At this point, we have the access token, and we can request service. So when I click this button, that'll send a request into Apigee, sending in the access token and the verb and the path. And when I send that in, I get a successful response, status 200 response, and a payload. And Apigee's just sort of added in some response information there. Now, if I change this path to something else, I can send in a request, the same request, and it is, I get a forbidden response. So Apigee is behaving differently depending on the path. Where does that stuff come from? Where does that decision come from? It comes from Open Policy Agent. So Open Policy Agent is that container that is running in Cloud Run for this example. And it also exposes an API, which I can use from this web app. So one thing I can do is check the configuration in that Open Policy Agent, and this is the configuration that relates roles to permissions. So here we have role reader 1 that has access on flow 1. Reader 2 has get access to flow 2. The special role, the role called special, has get access on flow 1 and flow 2, and so on. Where do the roles come from? I can also look at some other configuration inside OPA. This one relates specific users to roles for those users. And likewise, I might apply roles to specific domains. So in this particular example, I show that, you know, if you log in with a gmail.com domain, you're going to get this special role. And harking back to the permissions for that role, that means you'll have get access to flow 1 and flow 2. So if we try the APIs, we should see flow 1 and flow 2 work, and that is what we're seeing. And anything other than that, flow 3, 4, and so on, will not work. We get the 403, and that's because Apigee is calling out to OPA, asking for a decision, and then enforcing that decision on the response that it gets. How does this really work under the covers? Let's go to Apigee and we'll turn on a trace and we'll see that work. So here I have an API proxy defined in Apigee. The first thing I want to do is describe to you the configuration that I put in here. I enabled cores for the API proxy so that it can be called from a browser. The steps that it goes through are: first, verify the inbound access token. Check that it was issued by Apigee, still valid, not expired. Then then call out to the authorization engine, and this is a service call out policy in Apigee, and we can have a look at what that looks like down here. Basically, it's saying pass in the user, the authenticated user email address, the verb that is being requested, and the path that is being requested. And we want to know, is this allowed? The response that comes back will be an allow or deny. Based on that, the response that comes back from there, we'll extract the allow or deny, and if it is deny, we'll send back a fault, otherwise proxy to the upstream. So basic kind of operation inside this API proxy. Let's turn on a trace, and we'll actually see those policies working as we use them. So now back to the user experience. We've got our access token. Let's try performing a get on business flow 4. And if you remember, that's still denied according to the OPA rules that we saw, whereas business flow 1 should be allowed, and it is. So flipping back to the trace in the Apigee window, here is the first one that is a get on flow 4, and you can see the Apigee proxy verified the inbound access token that was presented, just to see that it's not invalid. That's an OAuth token. Then with the attached identity, called out to that authorization engine and received back the decision. So what we sent was this. Here's the user that authenticated. This is what they want to do, and this is the path they want to do it on. And got back the response that said, here's your decision. We're not going to allow that. This is on business ops flow 4. So disallowed, and then we get the fault sent back. For the case where the operation is allowed, this is the one where we called flow 1. You'll see it is allowed. The result says, yep, there's an allowing role. It's the special role. And it's permission number 0 in that special role. So we're going to proxy that to the upstream system. That's what Apigee does. So the result is that you've got this separation of concerns, and regardless of how the user authenticates or what the upstream system is, you can use Apigee to enforce authorization using OPA as the definitive policy decision point. Now, if I change this, let's say I want to change the permissions to a more relaxed allowance. So here we see now special has not just get on flow 1 and 2, but 3 and 4 as well. And I can flip back to the APIs and try flow 4, which before was declined. and now it is being allowed. We're allowing it because we've updated OPA, and Apigee is relying on that new updated authorization information. If I want to lock that down, I can turn off all access, and now I can see that there are no permissions for any user. Flipping back to the UI that allows me to send a request, if I send that in, that's going to be rejected. Even flow 1 will be rejected in accordance with the configuration that we've got there. So all that's really nice. The OPA itself is running as a Cloud Run service, so I can have a look at that. There's some, as I click into Cloud Run on the service, I can see some metrics on that. Maybe before we get into that, I just want to point out that this is just a standard container image for Open Policy Agent. Haven't written any custom code. The only thing I did was configure that Open Policy Agent to render authorization decisions based on the input that I wanted to use. And we get some nice metrics and observability on the behavior of the Open Policy Agent in the control panel here. I can also look at logs. So Google Cloud has lots of different logs. One of the things you can do is drill into the OPA decision logs. And if I click here, I can see all the log entries relating to a decision for rendered by Open Policy Agent. So the most recent one was here, and I can look at what the input was sent in. It was Apigee sending this in, saying here's the user, here's the flow. We want to understand if that's the resource, the path. This is the verb, and we want to understand what the result will be, or sorry, what the allowance will be. And in this case, the result is empty, which means it's denied. That's after we locked this thing down. And of course, we can see the other decisions and examine any of those. You can turn this off if you like, if it's too many log messages, but it's really nice to have that accessible for you when you're diagnosing, debugging these things. So what have we seen? We've seen federated identity, the ability to sign in a number of different ways with a single format ID token that can then be exchanged for an access token, and we can use OPA to decide to enforce access decisions for API access, regardless of how those APIs are implemented. Even if it's a SOAP system, if it's an older SaaS system that doesn't support sophisticated access control, you can use this solution to roll in access control onto those systems. I hope this has been helpful and informative. Let me know if you've got any questions. Until next time, keep it digital.